Hi, welcome to the second module. So the second module is about Earth observation data in Google Earth Engine. So we are going to see what are some of the data set that now we are going to look now how important is Google Earth Engine in terms of what data can we use in there, how are we going to use it, and so forth. So uh, the data that we can have in the types of data sets that you can have in Google Earth Engine, of course, include uh, Landsat, Sentinel, and MODIS, right? Of course, there are many others. We'll also look about how we are going to interact with this data as we continue. Right? So, what are some of the types of data sets that you can work on in Google Earth Engine? These data sets include satellite imageries, which, for example, can be Landsat, which we know, for example, Landsat 4, Landsat 5, Landsat 7, Landsat 8 or 9. There's also Sentinel, Sentinel 2 or Sentinel 3, right? That is Sentinel 1, which is synthetic aperture radar, uh, Sentinel-2, which is optical, and Sentinel-3. Also, there is MODIS and other resolution high resolution imagery, which means resolution up to maybe 2 meters. Yeah. So apart from satellite imageries, we can work with climate and weather information. This can be land surface temperature, atmospheric data, weather forecast measurements, and other data set that are available. We will look at them. So there is also geophysical data set that we can work on. These include digital elevation models. So these when DEMs basically to map the terrain, SRTMs. So these are also available on Google Earth Engine. Of course, there are free and paid. We will look some of these data sets. So don't be worried. Most of the data that are available there mm, you might have, unless you go for the high-end data sets, so that will require payment or require you to have certain accreditation for you to use them. So apart from geophysical, we also have human activity. This can be population or demographic data, infrastructure mapping, or even nightlife data. Nightlife data is also available where we can map how nightlight is for various cities or various towns across the globe. There is also agriculture or forestry, where we have cropland and data layers, forest cover, biomass, and other information. So for these, the core data types, of course, that we have in GIS is raster and vector. So all these data sets are there. So for example, when you talk about vector data, we have data for boundaries of countries. We have various raster set. For example, forest shape files for various global forests. These data are available depending on what you want and what your need is. So what are some of the processing that can be done in QGIS? Not QGIS, in Google Earth Engine. So pre-processing, first of all. What is pre-processing? Pre-processing, I can define it simply as preparing your data before you do whatever you want to do with it. So this is just preparing your data set before you analyze it or before you extract information. So the some of the basic things that we do, pre-processing that we do is cloud and shadow masking, atmospheric correction, and topographic correction, depending on what data set we are using. Cloud masking or shadow masking is simply removing cloud cover from a satellite image because, as the satellite goes around the world, there are some certain areas that are mostly foggy or have cloud cover. And so the image will be taken no matter the weather or cloud percentage. But each image captured has a cloud percentage attribute, right? And we can filter that using a certain function to remove certain percentage of cloud. So for example, an image was taken today, a satellite has a revisit day. So for example, if a satellite has a revisit day of 24 hours, if it passes today at 11 o'clock, tomorrow it will pass the same time, 11 o'clock. But today can have cloud cover of maybe 30%, but tomorrow it can have a cloud cover of 80%, right? So what you can do, you can use the image that we have of cloud cover that is less, which is 30% and 80%. So we can do cloud masking to use this other image that has no cloud, or to select only image that has clouds of less than 40%, which will use this image that was collected today of 30% cloud cover, and not use image that was taken tomorrow, which had maybe 80% cloud cover. So that is what we call, that's what we mean by cloud masking. Then there is atmospheric correction. So atmospheric correction, this is correcting a distortion that occur in the atmosphere, right? But some other data set have already undergone this, but in some case, you find that you have to do this. For example, you are trying to analyze and to realize, you're trying to do NDVI and to realize your image has just a lot of maybe this atmospheric distortion or a cloud cover. So that is where now you are required now to remove these factors. There is also topographic correction. This is mostly terrain correction, right? And this is correcting the variations in solar illumination caused by terrain, slope, for example, slope and aspect, especially in mountainous areas. So sometimes you see, when dealing with aerial imagery, we are trying to do something, for example, vegetation mapping. And when there is a hilly, when there is a hill and when there is a valley, without correcting it, so that we understand that at this point it's a hill and at this point it's a valley, we might find you're finding shadows of data and you think there are no data there, but actually there might be vegetation there, but it's just that it is a shadow when data was being recorded. So apart from um, pre-processing, we have also data transformation and composition, right? So other than the other pre-process where we are just removing clouds, we are removing maybe atmospheric distortion, we can also do other stuff like compositing and mosaicing, also calculating of spectral indices, and rescaling and scaling. So what is compositing or mosaicing? So this is just, for example, we are dealing with so many images, right? When we have so many images, for example, we are analyzing the vegetation of a place over a year, right? We might find that we have so many images because there is a revisit time of maybe a day. So each day has its own image. So to do mosaicing is where we now combine all these images to come up maybe with one image that will give us a median or a mean of how the general area looks like. So that is mosaicing. That's just finding the mean. So it's calculating a single image from a collection of images over a period, often by using a reducer like median or mean to get the statistical representation of the area. So there's also calculating the spectral indices This is, for example, this is obtaining derived indices from band combination, right? For example, an example is NDVI or NDWI. So this occurs when you want to derive certain information from satellite. So generally from a satellite, when a satellite moves, it captures not as our eye sees, it captures in bands. It has various sensors to capture each band. There is a sensor that captures the red band. Maybe there's a sensor that captures the blue band, and then there's a sensor that captures the infrared, among others. You find you can have a satellite having 38 sensors, depending on what satellite it is. So information that we get from this is now when we combine, for example, the red band, blue band, and the green band to get a real color image. So that will be now what our eyes usually see. So we can, if we combine these three bands, we can see what our eyes see. So that is now what we call spectral composition or band indexing. So we just calculate using these bands to find certain information. We can map various aspects. There is a vegetation index, there is water index, there is a build-up index, and also normalized build-up, normalized difference build-up index, depending on what we want to achieve. And this combination always uses various band combination. Another thing, there is rescaling and scaling. So this is just adjusting the raw digital number or the values by applying a scaling factor. This is, for example, multiplying by 100 or dividing by 100. So this, for example, this applies in most areas. For example, you want to calculate area where you calculate you can have your custom formula where you calculate, for example, from the from the raster, when you have the unknown pixel size, you can multiply side by side of the pixel by a certain scale factor to get area in hectares or area in acres or whatever you are doing. Then another thing, it's now after now the filtering and we go to importing and visualizing of satellite imagery, right? So actually this is the first step because we can't filter what we haven't imported. So first of all, we have to do data access and we select what we have, and then we identify the collection that we are doing. So identifying collection, this is to declare the satellite data you want to use. For example, Sentinel-2, and get it using the ID. We will see how we get using the ID. And then when we import it, we create it as an image collection. For example, if we are doing a band, right? We want to use a band 4 and band 3. We will import it as a collection. It will just come all of them, and then now we will do further filtering to get only what we have. Then we can define the area. You can declare it either as area of interest or whatever you want to declare it under your variables. So this is just filtering the collection using filter bounds, which is a Google Earth Engine function to limit the data to your region of interest, right? From the whole data, you just select the area that you want, and then you can define the time. Filter collection using dot filter date. This is also another custom Google Earth Engine function where you can filter the date and specify the start date and the end date. And also we can refine the quality to filter out low quality image or so that you can only have a high quality image. This, for example, when it comes to cloud masking, of course, the quality for when it has high cloud, it is a low quality image. So we need a clear image. And also we can do it to create a single image. This is, for example, reduce the image collection. As I have said, the mean, we can reduce the whole thing to have only one image per year instead of having 365 images that were collected each and every day. So another thing is visualizing and displaying the data. So we have to define the visualization parameter. It sometimes is abbreviated as viz parameters, which is visualize parameters, depending on how you are going to. Again, these things depends on how you are going to give your variable names. This is just a variable, and then we can create a directory or an object specifying the image display setting. These include, for example, if band 4, we have to give it a certain color or a certain stretch. This is when specifying the minimum and the maximum stretch that we want, or even maybe the opacity, that is how transparent it is, among others. Then there is another function when it comes to visualizing and displaying, which is called add layer. So add layer, this is basically to add layer to our map, right? You know, from the code editor, whatever we write, we see it on the map. So if you add a if you use the add layer, map.add layer, and then specify what you are adding between the brackets, that one will add your layer. And of course, you remember to add the visualization parameters so that it has your styling or the preferred styling that you want. Then also another final thing that we can have on our map is the map center or center map. This is where now you specify where you want your map to be centered. So we go to understanding image collection. So as we have said before, image collection is just that so many images that are coming together and we are working on them as they are together. So image collection, now this is where now we give a function, we can write a function to do changes on all these images at once, as compared to doing image on each and every image individually. For example, you're working on image collection for a month for a certain area. It will be a difficult task to do the 30 images one by one. But when you run them under image collection, if you write a certain change, it will just compute in all the images, and then you get an output still as a collection, right? So an image collection, from the definition, is a time series stack of images that share a common property. Like, for example, that can be the sensor type, the projection, or the pixel resolution over potentially vast spatial and temporal extents, right? So it can have a different spatial extent, which this is the location, or the temporal extent, which is the time that they were taken. So these we can understand, we can work with image collection in the following ways. We can filter by date and location, and also by the metadata. So filtering by location simply is specifying our bounds, which is we use the dot filter bounds, which is the geometry, right? We can have geometry in various ways. You can have an imported geometry, or we can just use custom geometry. For example, we can just draw using the draw tool, or maybe you can specify the points for each corners if it's, for example, a rectangle. So there are various ways that we can have geometry imported into our map, and this is mostly declared as ROI or AOI. You can have area of interest or region of interest depending on what your preference is and how you are going to give it as a variable. Then another way that we can filter is filtering by date, which this is temporal filtering, where we filter the time, and it uses dot filter date, and then you specify the start date and the end date. Yeah. So there are certain ways that you have to do these variables and strings. When it comes strings, numbers, and date, there are ways that you write date in Google Earth Engine. Of course, we will look at that. And then another way that we can filter by metadata. This is for quality control. For example, you want only a certain cloud percentage, right? We can filter these images to have a uh, certain percentage of cloud cover to ensure that we have quality data. We also have filtering for data reduction. This is, for example, the example that I gave. We have a satellite image that was covered for 1 year from January to December. And we want to know, for example, what was the first image. So we can only take the first image or maybe and the last image to compare so that we see how the year started and how the year ended. Or maybe we can say we want only one image for each month. So we are reducing the dataset from 365 images to just 12 images so that we can get how was the trend. For example, in January, the temperature was 30, in February it dropped. So this is for data reduction, and we can use function like median, or we can use first or dot last. These are all that we can use. Yeah. Yes. Also, there is a equality check, right? So this is to use the filter. This is the EE dot filter, and the reason is to select scenes that perfectly match certain criteria, right, or specific value. We are going to look into that. So briefly, let us go to the Google Earth Engine site. So this is our site from the introduction. From the other introduction, of course, we saw this is our site, Google Earth Engine. So it's just simple. This is our script area, our uh, docs area, and then our assets. So our asset is what we have imported to Google Earth Engine. Then this is the code editor area. This is your project name. This is where you get the link to share. This is the save function. This is where you run your script. The reset. This is where we create our apps. Of course, this is just the settings. The inspector is where we inspect our layer. Console is for example, when we are printing stuff, this is where we come, and then task. These are, for example, task. For example, when we are exporting or importing, this is where we are going to see the progress of our tasks. And then this is the map area, right? So this is the basic introduction. So to create a new script, you just have to come to new, and then you either choose a folder or a file. No, this is asset. So you come to script, and then you create a new, and then you choose a file. So the project, this is my default project. Also, this is a file, but under that file, I can create a new project, new project note where I'll call it vegetation um, in California. So that is a simple project that we have just created. So we have seen the various things that we can do. We can check for data set. For example, if we want to see data set, we just come to the search, and the search performs various functions. We can search either data set or we can search the location. For example, we want to map California. I can search for California. Wait, sorry. California. Yeah. when I search California, you can see it automatically zooms to the US. Yeah. And then depending on where you want to analyze, you can add your geometry in various, you can add it either as a point or as a line, right? Depending on what you are doing, or maybe even as just a drawing, a polygon, then you can complete it there, or as a square. You can also add it as a square, just like that, right? Yeah, and then these are you can see, oh, these are the drawings that I have done. So there are two polygons, right? Then there's this, so you can also navigate it. You can also even change the color, for example. You can change even the color. You can do various stuff. This is the zoom in, zoom out. Yeah, this is it. So also data set, we can still find here the data set. You can go to browse the catalog to explore what are the data sets that we have. We have, for example, surface temperature, climate, I have atmospheric, and it comes with some information or metadata that you can check them out depending on what you are doing. There is Landsat, there is Sentinel, there is MODIS, there is a high resolution imagery. So you can see, for example, this high resolution image capture finer details of landscape and urban environment. The US, for example, is US National Agriculture Imagery Program. And also you have to be keen on the coverage of the data. For example, we can open one image and then we explore what is the coverage. There's, for example, we can check out this. You have to understand your data first of all before you use, because sometimes not all the data that you're looking for will solve your the problem that you want to deal with. Maybe it's not even covering your area, and then you're trying to run scripts on them and you find it's not. So this is the code that you can use to call this data set. So this is what you can just add to your Google Earth Engine code, and then you get. Also, there are some code snippets that you can use. For example, here, you see. So let's just here we can use. For example, we want to use Landsat. Just elate. So this is Landsat 8 Tier 2. There's Landsat 8 Tier 1, Tier 1, and then Landsat 8 Tier 2. Right? For example, we open that. We can see the description. We see this is the collection snippet. This is what we can use to call it to our map. And then there are the bands now. This now we see what band collection does this imagery have, right? There's all this, depending on what you are doing. And also, if you want to understand what these bands are, so you can check through this metadata before using the imagery. So there is the guidelines. You can go to that and then you explore it further. Yes. What else have we not? What else have we not? So we have seen how to. So you see the geometry that we drew. Here they are. For example, there is this. variable one, variable. So after we have done this now in our code, we can use them because they are imported already. You can see the imports are 2, but we can just remove them by deleting. Yeah. Yeah. So thank you, and let's meet in the next as we look now to understand more about the variables and the variable and just writing a script now to solve the problem that we will. Thank you.